to our last installment of POODR Book Club, Chapter 9. I'm Mary-Katherine McKenzie. I've been coding for about a year now. Yeah. Do you want to introduce yourself?
I'm Clayton Flesher, Ruby developer, and I've been coding for, wow, it's coming up on a year and a half now.
Nice. All right, cool. So I'm going to start the PowerPoint. And make sure broadcast. Hide. Okay. All right, can you see the PowerPoint?
Yep.
Cool.
Be sure to tag yourself.
What? Oh, yeah.
Wow. Yeah, I think it'll, yeah.
I think I did that. I'll double check. Oh, yeah, I got it. Cool.
Okay.
All right. Chapter 9, Designing Cost-Effective Tests. So let's kind of start with a summary. She says tests are indispensable. The best tests are loosely coupled to the underlying code and test everything once and in the proper place. So she starts off by saying, 3 skills for writing changeable code is, first of all, understanding object-oriented design, which we've spent 9 weeks doing, refactoring, and being good at testing. So we've kind of covered refactoring, and now we're jumping into testing. So the emphasis here is on intentional testing. So the true purpose of testing is to reduce costs. Tests may be costly when you first learn how to do them, but they will improve over time as you become more skilled at writing them. And this is reiterated often. She lists some benefits of testing. One is finding bugs. So as you're going through, you can obviously, if things fail, it's a good indication that you might have something wrong with your code. Supplying documentation when we're talking about things like duck types or roles that are kind of invisible to everybody except for you in your head. It's a good way to document them. So she suggests writing your tests as you expect your future self to have amnesia. Deferring design decisions, which she emphasizes a lot in the book, and tests will continue to verify good behavior as you refactor. So also supporting abstractions, consolidated place where behavior of the whole is made clear. She uses bicycle as an example of this, where you might have, gear inches and the parts and pieces of a bike, but you might not know that those make a bike until you explicitly define it, which you aren't going to be doing in your code anyway. In this case you will be, but not always. And also exposing design flaws. She compares tests to the canary in the coal mine. So, and also you can tell if a test is too hard to set up, then the code might expect too much. So there are different things you can kind of tell by how you write your test. You can kind of tell the quality of the code.
This is actually, this is really helpful because while I do write tests, and you learn testing way after you learn, a lot of the core fundamentals of Ruby, and or at least I did. And I'm still not the best in the world at testing. It's actually got a lot of ideas and stuff, like the whole, well, we'll get into it, but yeah, my tests are very dependent on multiple objects and things right now, and they're going to get better because of this chapter.
Right. Yeah, she does a really, I've been trying to learn about tests for a really long time, but I feel like I just haven't kind of grasped the core, why you should do it. But now, obviously she lays it out in neat bullet points, but now it makes a lot of sense, other than just making sure that your code works.
Right. Well, if you're maintaining an app, having tests is it's just a godsend, because if you need to change something, if you break a few tests when you change something I've had tests break that I weren't expecting to test after I've done a refactoring, and it's so much better to have that happen than have it happen free than you to find the bug after you've deployed.
Right. Yeah. You can see how that would be helpful. So in the next part, she says, you also have to know what to test, because it's possible to write too many tests, because you just want to test everything once and in the proper place. And I really like this analogy of the black box. So the messages, you should only be able to see the messages that your object sends and receives, but anything else is kind of in its own little capsule, like this space capsule that she has illustrated here. And so you can't, you see the messages, but you don't see anything else, essentially. And she also says to write tests for messages defined in the public interface, which is also, as she's defined before, should be the most stable thing about an object. And so we kind of have different categories of messages. So there's queries and commands, but we also have tests of state that make assertions about the values that messages return. So we don't need to test outgoing messages for state, only incoming. Because if we test both incoming and outgoing, then we'll be duplicating tests, and that's not what we're going to do.
You'll end up writing the same test. You'll be testing the same behavior in two different test suites or class tests.
Right. Yeah. So that's not what we want. And so she talks about queries and commands, and queries are outgoing messages that have no side effects. So the sender cares about the result, but nothing else in the application does. And she notes that these don't need to be tested. And commands, outgoing messages that do have side effects, it's the responsibility of the sending object to prove that they are properly sent. And do you have a good example of something like what a query versus a command would be? I think we go into it, but just.
She gets into it a little bit. I don't remember I'd have to look at her examples to have a good idea of the distinction she draws there.
Right.
That was when I first read that, before I saw any of her examples. That was my first introduction to that idea.
Okay.
So,
cool. So I'm not too far behind there. So yeah, we've got, let's see what she says.
I know all of the examples she gives later are things that do need to be tested. That's all pretty intuitive.
Right. But she talks about commands, which she gives examples for. She says outgoing messages do have command messages do have side effects. Examples: a file gets written, database record is saved, an action is taken by an observer. And these actions, your application depends on these actions. So
yeah, so like something that saves a record somewhere to some file or something that like creates a new instance of an object or something like that, maybe.
Yeah. So what I'm wondering is so what is a query in contrast to that? So if we know what commands are.
So if nothing else in the application depends on the message. So I guess in a query that might just be, I don't know. We'll have to look at her examples and go, because I don't know that she has any examples of just queries in her code. We'll have to look and see.
Yeah, because I don't remember seeing any explicitly defined. She might have some, but they're not, pointed out.
That might be something worth asking about.
Yeah.
This weekend.
Oh yeah. Let's see.
I also learned a lot about mini-tests from this because I'd never used mini-tests.
Yeah, I haven't either. I mean, I haven't used any test suite.
I use
But
RSpec, so.
yeah, that's the popular one now, right? That's kind of
Yeah,
what everybody
yeah.
uses.
Mini-test is, I think, what comes, like, well, mini-test is bundled in Ruby, and it also is like the default, I think, in Rails, but almost everyone uses RSpec. It's not hard to, like, tell Rails to use RSpec, everyone.
Right. And do you know why people use RSpec over mini-test?
Yeah,
Or is
well,
it just
it's more fully featured, I think. So you can,
okay?
like, you can, it's just a more robust testing system and has more features, I think. And I also like the syntax. After looking at this, unless mini-test has changed its interface since this book was written, the syntax and interface in RSpec just is a lot more intuitive to me. It's like, you know,
Okay.
it's like expect this to equal this, and it either passes or fails.
Gotcha.
And the kind of message you get. So like whenever you define something in RSpec, you define a, like, it should whatever, and then you have a do block. And everything between the it and the do is a string. And when your tests pass, so your tests actually use that string that you use to describe that particular test as the message when you get errors. So it's really, it helps you write your own error messages and stuff. RSpec's pretty cool.
Yeah. Yeah. So, I mean, it sounds like that's kind of the default.
It's the go-to these days.
Right.
But mini-test looks like it would be fun to play around with, and I might use it on an app sometime just to get it familiar with it.
Right. I mean, I've definitely heard of people using it before, like, because this isn't my first time I've ever heard it.
No. Yeah,
So,
it gets used. It's just not, well, I think Exorcism, I think all of its tests are written in mini-test. Which would make sense because mini-test is a lot more stripped down. And so if you're doing something like Exorcism where you're sending, you know, you're sending big packets of, you know, stuff back and forth to the website, it might be that mini-test, because it's built into Ruby, that's one less dependency you have to worry about with your big application. And also it might be like a time, like a, you know, it might help with sending out less large files getting passed around and stuff.
Right. Yeah, that makes sense.
The dependency thing seems like it would be nice because, you know, our spec's going to change over time.
Right. Yeah. Yeah, and I guess it, yeah, like you said, it helps that it's bundled.
Yeah.
So, okay, so we have, this is kind of her last, or her like kind of summary of what to test. So she says, incoming messages should be tested for the state they return. Outgoing messages should be tested to ensure they get sent, and outgoing query messages should not be tested. So now we just have to know when to test. Now that we know what to test, when to test.
Right.
She says write the test first when that makes sense, but this also doesn't guarantee that your application will be good just because you write your test first.
So a lot of you say that makes sense, but that's not how a significant portion of people do their testing. A lot of people write code and then write tests to cover it. And I'm not going to lie, I do that a lot.
Right. Yeah, I've definitely, I think she kind of like sort of addresses that too. There's like a paragraph where she's like, you know, a lot of programmers, especially experienced ones, will have a hard time going back and writing tests first if you haven't been doing that from the very beginning. Because it's a habit you have to get into, I assume, too.
Well, if she gives a good argument for why you should do it, it steers you in a certain direction that's more friendly to like the tests themselves will actually push you in a direction that is more likely to be the POODR style OO design.
Right. Yeah. But I mean, then again, throughout this example, she already has the code written.
Yeah. No, you're right.
it's clearly like you can do it either way, but I do get that writing test first would make sense in this case. And she does, yeah, go ahead.
So I think the happy medium is messing around with untested code until you get something that sort of kind of does what you want it to do.
Right.
If you're not sure how if you're not sure how to even make it work, if you don't, like, if it's on the edge of your knowledge set, mess around with it until you get something that's sort of close, and then write a test that is the rest of the way of what you want. But because by then you'll have an idea of how you're going to structure it.
Right.
And
So
then
it's like,
you throw out throw out everything before that and try to make the test pass.
yeah, that seems like the right way to do it, or at least at first.
And I've heard of very experienced programmers doing it that way too, and that's what I'm trying to move toward, is that because at this level with both of us, there's a lot of times when we're writing stuff that's really on the edge of our knowledge set. So to write a test first, sometimes we don't even know what the test needs to test. You know what I mean?
Yeah. But I guess she's kind of nudging that, kind of like, this is like, as long as you know what you need to do, you should be able to write tests for it. But I mean, that obviously it's not always the case, but
right.
Sometimes you don't know what it needs to do. But then she does kind of go through like, it's if you have good tests, they can be reused and whatnot.
Right.
And then immediately right off the bat, like, well, I want this to have this kind of behavior. I already have a test for that.
Well, and she assumes you're going to be doing, I mean, even with the structure of this book, she assumes you're going to be doing a lot of refactoring, both of your code and your tests.
Right. So now that we know what to test and when to test, we just have to know how to test. And this is where she kind of goes into mini-test versus RSpec, but she doesn't go into it more than a literal sentence.
Let me see if mini-test is still bundled with Ruby, or if it's been broken out. Let me look in the core Ruby here. It's in the standard library, I think, still. Maybe not. Mini-test may have been.
So it is in the standard library?
No, I'm not seeing it. Hang on, let me see. Ruby 2.2.3, mini-test B2.2. Yeah, they removed test unit and mini-test from Ruby 2.2 and made them, they're gems now, just like RSpec is. Okay. So that's interesting. So the Ruby core team has decided they're not going to pick a side anymore, and they're just going to let you decide what gems you decide to use. That's interesting. So that really does mean that mini-test is really kind of seen its day, probably. Right. Yeah, I guess so. Yeah, because I mean, she's talking about Ruby version 1.9. So right. Well, in 1.9 up until 2.2, it was bundled in Ruby. And or at least it has been, I guess, since it was in 1.9 and it was up until 2.2, and from 2.2 forward, it's no longer apparently bundled. It's a Ruby gem now. Right. Because I think I've seen it as a Ruby gem, but yeah. But I don't know. Anyway, so these both, and then she also talks about test-driven development, TDD, versus behavior-driven development, BDD, and how BDD is more outside in and TDD is more inside out. I
both
learned
rank first.
TDD, but
Yeah, I've heard people using more TDD, but
I
I
know.
don't.
So Sarin does some DDD. Like
Hmm.
that's how behavior. Let's use the word because it's hard to tell sometimes what you're saying.
Yeah, that's
Um,
true.
Sarin uses behavior driven some. I know she has because she talked about it when she was showing me her what she did when she was writing and refactoring some of the code on the actual CodeNewbies website. And then
Okay.
test driven development was how I learned to do tests. As far as I know, like it was like red green refactoring. You know, you write a test, you run it, it fails, you write code until it gets green,
Right.
and then you write a new
And you
test.
refactor. Yeah.
Yeah, or yeah, red green, then you refactor, and then you write a new test.
Hmm. Right. So I've seen, I think I've seen both. Um, but I guess so I think with TDD, you kind of do like the smallest components first,
Mm-hmm.
and then kind of go out and see how they all relate. And with behavior driven, it's the opposite. You kind of do the big stuff first, and then you fill in everything in between.
Mm.
That's how I understand it. I'm not sure if that's 100% correct, but
That's close to how she described it.
right.
Yeah.
Yeah, that's kind of, I guess that's what this picture kind of shows.
Right.
So she also goes on to say, like, you have to think of your objects in your code as being in two categories, the object under test and everything else. And the object under test should remain ignorant of everything else.
Right.
So this is also kind of how you make sure that everything's independent and, or that, everything's not like super tightly coupled, because if you really
Right.
have to pull in a bunch of other stuff in your test, then maybe you should look at refactoring your code. But if you're
Yeah.
writing your test first,
Yeah. If you're writing your test the way she wants you to, your code has to be loosely coupled
right.
because you're
So,
not. I mean, yeah.
right. You're not going to be able to write your test if they're not.
Otherwise, testing is going to become a nightmare very quickly.
Right. Um, and so she then goes on. Well, so in this same chapter, she kind of goes on to talk about the many test framework, and it's just like 2 paragraphs. Um, and she also says, don't worry about how it might change in syntax. It's just the underlying goals that matter.
Everything she shows in here is
Mm-hmm,
stuff you can do in RSpec.
right. It's just the examples are many tests, but everything that she says is universal,
Right.
which I mean is obviously on purpose.
Yeah. It's gonna. There's a version of it. The syntax is different, but the actual behavior and what you would actually do is the same for both. For any
Right.
fully fleshed out testing framework.
Right. And I think it's good at showing kind of when it has the test and if they pass and fail. I'm assuming most test suites will give you the same kind of information. If it
Yeah,
doesn't.
they'll have a like. So when you run tests in RSpec, if it fails, you'll get which test failed and where inside of the test it failed.
Mm-hmm.
And it'll tell you like if you had expected, if you never even got to expected behavior, if it just failed because of like an error because some method was missing or something, it'll let you know that. But if it was like
Mm-hmm.
some expectation failed, it'll let you know which expectation failed, and it won't move on to the next expectation until the previous one passes. So if you'll know like okay, you'll know exactly where it failed in
Hmm.
your expectations,
Gotcha.
and everything else before it you'll know was passing, because if that's the one that failed, then the ones, if you had multiple expectations inside of the test, and like let's say you had 4 and the third one failed, the first 2 passed.
Right. Right. So it's pretty much, yeah. So it's just syntax and the examples that are different, but yeah, I really like how everything's pretty like test suite agnostic. So also, this is probably irrelevant now, but if anybody does come in, will you let me know?
Yes, I will.
Okay. So let's see. The next section is testing incoming messages. And she says the incoming messages make up an object's public interface, which is the face it presents to the world. Incoming messages must be tested.
Right.
So now we're going back to kind of code that we looked at in chapter 3. Before we refactored it completely, it still got some of the dependencies. In this case, it was line 24, where gear creates an instance of the wheel class. And we go on in chapter 3 to use a dependency injection, I think was our final kind of solution to that problem.
Right.
And the table 9.1 down here shows the messages that cross these boundaries. So it shows you the incoming messages, the outgoing messages, and whether or not it has dependence.
I like that she doesn't. She shows you how to test the code at every level. She doesn't just expect you to test the perfect code.
Mm-hmm.
She's like, this is the code that, like, here's the earliest version of it. I'm still going to show you how to test that, because at some point you're going to be writing the crappy early stuff. And
right.
You need test for that too.
Right. Well, yeah, and then we eventually get to the same result, right? So it's like we test it, find out it doesn't work, and then we refactor it, as opposed to just being like, oh, this doesn't work. So I guess this kind of, I mean, this really is the last chapter, because she goes through and is like, you know, you've refactored all this stuff now and you know how to do it, but it may not have been obvious that you needed to right off the bat. Mm-hmm. And like testing will help you realize that it's necessary, or where it's necessary. And
also when you're doing it, what breaks.
Right. So here she says, you know, incoming messages ought to have dependence. And if it doesn't, delete it, because it's not actively being used. If it's just a message that's being sent out and not being used, don't use it.
Well, if it's a message that's being passed in and not being used.
Right. Yeah. Like, why is it there?
Yeah.
So, and she notes that it, you know, costs more to keep than it does to recover. So it's easy to pull it back in when you need it, but it's hard to test something that doesn't do anything. So now we're going to prove the public interface.
That's part of, so that actually, if you hear about like, don't anticipate, don't design ahead, don't write code that's that you're not implementing yet, like that's an example of her pushing back, her pushing in that direction.
Yeah.
Saying don't write code you're not using yet. You know, don't be passing stuff into your classes that you're not actually needing.
Right. Yeah, and it's the whole like defer design decisions mantra. Just, you know.
Exactly. Yeah. Exactly. Yeah.
Yeah. So now proving the public interface, we've got the first requirement for testing an incoming message is to prove that it returns the correct value in every possible situation. So here we're going to be testing diameter, and testing it within wheel is pretty straightforward. Diameter, as we saw in the last table, is an incoming message for wheel. So that's pretty straightforward. We just test it, give it values, and see if it works. But testing gear is a little bit more complicated. So here we're testing gear inches within gear, and so it's not immediately obvious that wheel and gear are coupled. We see it in the last. Let me scroll back to that. In this code, we can see it on line 24. But if you're just looking, if you're just looking at the test, you might not know that immediately.
Right, which is why you want to write classes where you pass. If you do have dependencies, you want to pass them in, because it makes it more obvious for your tests. You don't want to initialize will inside of your class if you don't have to, because then it hides it from your test.
Right.
If you change will, you break your gear test and you don't know why.
Yeah. Yeah. So she says that here, if will gets messed up, this test might fail in a misleading way.
Right.
So you see it fail, but you won't necessarily be able to tell why in gear straight off the bat, because it's not obvious. So, and then I guess we kind of explore that. So isolating the object under test, your test goal here is to ensure that gear inches are calculated correctly. Our problem is that we're running gear inches relies on code in objects other than gear, specifically the diameter method in the wheel class. We fix this initially in like chapter 3 by injecting a dependency, and we'll do that again here. In line 12, the diameter method now is in the diameterizable. That's the weirdest word.
It's a hard one to say. I think
Yeah.
I say only in a book. Maybe.
Right. Yeah.
Diameterizable.
Diameterizable. Diameter. Yeah. Okay.
But so, do you see why? Okay. Do you see why you can't isolate gear without it? What you can't isolate the object being tested from other objects unless you inject it.
Right.
Like there's no way to isolate gear away from wheel unless wheel's being injected, because if wheel's being instantiated inside of the class, the tests are just can't be decoupled from one another.
Right. They'll never know that they're testing another object completely.
Well, and it also makes it impossible for you to use things other than wheel.
Right.
And in gear.
Mm-hmm.
Which is something she talked about earlier in the book.
Right, like other things have diameters that aren't necessarily wheels.
Exactly. Which is
so
that's where you get the diameterizable roll.
Right. Which right now only has one thing, but could have other things.
Right.
Which is something she kind of warns against, like we just said. But I guess in this case, it's good to have. So now we updated the test to accommodate the dependency injection of instantiating wheel inside of the arguments and not inside of the method. So we see that in line 6. Now it's more obvious that gear is using wheel because we have to consciously put it in every time instead of
it's still not technically isolated, but at least now it's obvious that it's dependent. Before it was before it was both not isolated and hidden.
Which is two bad things.
Right.
Let's see. So now injecting dependencies using class. She notes that your tests should always break when they should. An example of when they don't break when they should is we changed diameter to width, the method name itself to width in the wheel class, but gear still depends on diameter. So now the tests fail as they should because you messed something up. You know there's something wrong with the diameter method.
And as long as you only have a gear and a wheel, like that's great. It's when you start having multiple things that have diameter or multiple things that have width that you start needing the roll. Which is what she, like when she talked about the diameterizable roll, like, so we're not to the point where we even really need that yet because we only have the one thing that has diameter.
Yeah, so we only have one diameterizable, whatever.
Yeah.
So now she kind of shows here this little diagram, injecting dependencies as roles.
Right.
So two places where an object depends on knowledge of a diameter. This is too complicated.
Yeah, it's a hard one.
So one is where gear believes it can send diameter to injected object, like wheel, I guess in this case. Two, expects injected object to implement diameter. So.
Hey, we just had Alexandra hop in.
Oh, cool. Hello.
Hello.
Do you want to introduce yourself real quick? If you can.
You're on mute.
Oh.
Or she's on mute. She says hi, sorry. You're fine. She's working, so she's just going to listen.
Cool. Okay. Well.
Welcome.
Welcome. So, okay, we are at, if you're following along, we're at page 208. Okay, so let's see, where were we? All right, so we've got wheel that behaves like a diameterizable and is injected to gear. So now, I don't really know what the point of, I guess I was just showing how.
All right, so, well, it's just showing how, okay, so everything that behaves like a wheel, which means has a diameter method, would be, you're not actually, you don't want to actually pass wheel into the test because that makes gear dependent on wheel. And if you decide you want to use something other than wheel, you don't want the test to just depend on wheel. You want it to depend on like the role. And so you create a diameterizable class which has the same method as wheel, but you don't actually have to use wheel. You use like a diameter double.
Okay. Yeah, and so that's what we get into here, using diameter double. A test double she defines as a fake object that in this case plays the role of something having a diameter. So we create that in line 2 in this code, and then we inject it into gear in line 13. So she says this double stubs diameter, that is, it implements a version of diameter that returns a canned answer. She does make the distinction that this is not a mock, which we get into later, but this does pass.
Right.
So
there's a danger here. If you go and change will, the test is still going to pass.
Right.
So we'll have to deal with that in a little bit.
Yeah. So I guess I'm just a little bit confused. So I guess I'm just, why do we do this?
This isolates here so that it does not actually depend on any other.
Oh, okay, I see.
This is where you get the isolation. See, before
Gotcha.
we didn't get isolation. We just got that it was obvious that it was being passed in.
Right.
Now we're getting genuine isolation where the gear is actually not relying on any other class that's being used in the actual code base to be tested.
Right, okay. So it's because it only depends on something having a diameter method. In this case, we're literally just creating a class that only has a diameter method.
Yeah, and the class does not, diameter double does not get used inside of the actual code base. It's only being used in tests.
Right. Okay.
That's that's why it's called a double.
Right. Okay. So that makes sense. So, yeah. So she creates this double, and yeah. So next we get to this thing she calls living the dream. So in the previous example, we created double and it worked. What if diameter changes to width? Your diameter double means that the test calculates gear inches will still pass. And I think the whole living the dream thing is that you've now created this fantasy world that, diameter still exists, but it doesn't.
Right. Because if you change will, you've got to change diameter double, or it's because it's isolated. It's like you have a new kind of dependency where you need, like diameter double and will need to inherit from this, or like they share. They need to be you need to be aware that when you change one, you got to change the other somehow.
Right.
And that's
Yeah.
show us a way to get there.
Right. So yeah, in this case, it's just diameter double is of the same role as wheel in that it has a diameter class, but that's not explicitly defined anywhere, so you don't necessarily know that that's the case.
Which is not. This is not something I had ever done before. I've never written doubles. I've always just passed in. Like I've gotten to where like I just explicitly pass in classes everywhere. I try not to instantiate classes inside other classes like she wants us to. But when I test it, I always just pass in another class that's already being used in the code base. This is my first time really running into doubles.
Right.
So,
do you think it's something that you would use, like as a useful piece of information?
Yeah, it's something I actually need to go back and do for my application that's in production.
Okay. Cool. Learn something new. So now we go back and talk about how now that we have another thing that also has a diameter method, it now has a role, but we don't have anywhere to document that. So she said, the earlier problem was because the role was invisible, but now we can document the role with tests. So it's still incomplete because it can't be shared with others in the same role, and gear inches can still pass. So roles need a test of their own. But we
Alexandra went ahead
document
and
it.
dropped out. She said she'd watch the recording later.
Okay. Bye. So the where was I? Oh, so now we document the role name and kind of what it does in line 6. But like she said, this isn't perfect. So she goes on to say this choice between injecting real or fake objects has far-reaching consequences. Injecting the same objects at test time as are used at runtime ensure that tests break correctly but may lead to long-running tests. Alternatively, injecting doubles can speed tests but leave them vulnerable to constructing a fantasy world where tests work but the application fails.
So let's unpack that a little bit.
Yeah.
It might be a good idea in my current application, because it's not a huge application and I don't have a gigantic test suite yet, for me to not use doubles, for me to actually just keep injecting instances of the classes that I'm using, because it'll just break and it gives me useful information. But as an application grows with the code base, or as the test suite grows with the code base, there's going to be some point at which the trade-off is obviously in the other direction, where you don't want to have to run a test suite that takes a really long time to run every time you run your tests.
Right. So it's kind of one of those things that might be optimal at some point, but you don't do if it's not cost effective.
Maybe not if the app's real small.
Right.
That's interesting. I did actually miss. I know I read that, but at the time I didn't catch that was a trade-off that she put forward.
Right. Yeah, she does a good job of talking about trade-off between methods or styles and design.
I wonder when it becomes. So I wonder if there's any good blog posts or anything that people have written about when it becomes worth it to switch
like a quantifiable breakpoint kind of.
Yeah, like where's the trade-off start going in one direction or the other, or doubles really something you should just kind of start doing from the beginning? Because I would imagine, well, maybe not. If you're writing this style of code anyway, it wouldn't seem like it would be that big of a deal to introduce doubles. And even if you just didn't introduce them all at once, you just introduced them to like parts of the code where the tests were particularly slow.
Right. Yeah, because I mean, the tests don't affect your like production speed, right? Like your actual runtime.
No,
it just like.
But if you're having to refactor a code base and you got to run your test suite after all, every time you make any kind of change, and it takes 2 minutes to run your test suite,
right.
That's a problem.
Compounded, right?
Hang on a second. Sorry, I had to say goodnight to the kids.
No, that's fine.
So I don't know. I'm curious what people watching this will think when it's a good idea to start introducing doubles, because like I don't think the app I have now, it's probably not big enough to worry about, because like the thing that's slowing down my tests is not the fact that I have doubles. The thing that's slowing down my tests is the fact that my tests are actually making API calls, and I shouldn't be making API calls on my tests.
Right. Right.
That's the bottleneck for my test suite right now. And even then, my test suite's still not very slow. Like relative to how long it takes for me to make any kind of refactoring, it's not very slow.
Mm-hmm. Right. So now it might not be worth it to go back through and.
Yeah,
like
if I was going to make a change, I would introduce something like VCR that records API calls and then uses like copies of those recordings as like seed data for the test, which is a really, I need to do that.
Now you have a to-do list.
Yeah.
Okay.
Sorry, I derailed.
So, oh no, discussion is what we're here for. So now we get into testing private methods, which,
don't do it.
Yeah, right. Don't do it. She does say, don't,
but
you can do it. She says, okay, so private methods are defined as messages sent to self. So messages sent to self invoke methods that are defined in the receiver's private interface. Ideally, this is invisible because it's unstable. You put all of your unstable stuff in private methods. She does say, earlier in the book that you can, you should depend on public interfaces. Private interfaces, not so much. Ideally, they would not be tested at all, but we do not live in an ideal world. So
if you're testing all of your public methods, and they're passing, that's a test of your private methods, because your private methods are the logic that's going on in the background to make your public methods work right.
Right.
So
yeah, and she kind of gets into that too.
Yeah, like you should never. You shouldn't. I can't imagine a situation where you really like, unless you just have a stupid long method, and it's just a huge big bundle of crazy code. I can't imagine a situation where and you don't want to write that kind of code anyway. Can't imagine a situation where you really need to be testing your private methods.
Right.
She doesn't even want you to use them if you don't have to, which is not like that was new to me, because I like private methods are a go-to for me. I like to put as much stuff behind private wall as possible.
Yeah. Well, I think like, like with everything else, it's one of those things where maybe like as you kind of get better and are more confident in doing stuff, it's not as necessary to put it behind a wall.
Well, I think it's more along the lines of once your classes get shorter and smaller, ideally she wants you to only have 1 or 2 public methods as well on most classes. And so she just wants your classes to be small and not have a ton of logic in them. And if you don't have a ton of logic in your classes, you're not having to hide logic behind private methods.
Right. So yeah, so she does kind of make a big deal about not testing them, but then she does kind of side note in that she's like, well, you shouldn't really have them at all. But then she goes into reasons not to test private methods. She says, like you were saying earlier, these tests are redundant as the methods that invoke them already have tests. So you're not, your code isn't dry if you're testing private methods.
Do you understand how private methods work?
Kind of. I mean, I know it's like there's nothing keeping you from actually using them.
Yeah, there is. Like if you make them private, you can get to them, but you have to make like an explicit. You have to like make a very explicit, like tell Ruby I want to send and this name of this message, and it'll call it. But
Right.
if you call just like dot and the name of the private method, Ruby's going to go, I don't know the name. I don't know that method.
Okay. Because
And
I think
so,
because we had been talking about it at an earlier one.
yes.
And I think it was maybe Java that actually says, like, even if you try to call it, it will not let you under any circumstances.
Maybe.
Whereas with Ruby, you can do it, but it just like takes a lot more effort.
You have to be really explicit that that's what you're doing.
Right.
Ruby makes you
Right.
Ruby makes you tell Ruby, yeah, I really mean this. But the whole point of private methods is, let's say you have a public method that takes some argument and returns some Boolean, for example.
Mm-hmm.
That may only be 1 or 2 lines of code, but it might not. It might be a bunch of code. And if it's a bunch of code, you don't want to put all of that inside of that one method. You want to kind of break that up. And if you have multiple places inside of that bunch of methods where the same thing's happening over and over again, you break that part out into a private method so that that part of that public method, when it's doing its logic, can grab that private method and do what it needs to do. So a private method is just, it's a method inside the class that the class uses to do work, but it's not for the outside world. It's only for the methods inside that class.
Okay. Okay, that makes sense.
Because you can call a method that you've already defined on a method inside of another method in that class. And that's what private methods are for. Those are methods that you define for other methods to call and use.
Gotcha. So it's like a black box with inside of a black box.
Exactly.
You only see the messages.
Yeah. You don't ever see the private method. You don't ever call the private method on the class. The class itself just uses the private methods within the structure of the class.
Gotcha. Okay. Yep, that makes sense. Yeah, so she goes on to say the private methods are by design unstable because I guess as long as they're still returning what they need to return, you can change the logic behind it.
Yeah. Yeah, that's another thing. Yeah, if you can do whatever you want to private methods and people won't freak out because people aren't supposed to know about them anyway. So if you change their behavior, that's on the people who are breaking the rules and sending explicit messages.
Right.
You can refactor that and change the behavior. And as long as the public methods still do what they're supposed to do, that's on whoever broke the contract.
Right. Right. So that's not on the programmer. That's on the
that's why I like to hide as much as possible inside of private methods, because then I don't expect any kind of, like, nobody has any expectations of those methods being available. It also, but then again, it makes those methods impossible to test, except unless you test all of your public methods.
Right.
Which you should do anyway.
Right. Yeah, and so like you're saying, by hiding them, people can't really get to them, but if they're documented in tests, people can see them.
Yeah, and she said earlier in the chapter that tests are documentation. And so if you are testing them, you're documenting them. And so people will use them.
Right. Yeah. So you don't want that at all. So avoid documentation if you don't want people to use your stuff.
Right.
So and she kind of gets into avoiding private methods altogether. So she cites that too many private methods may indicate too many responsibilities. Maybe you want to extract those methods into a new object. But she also she notes that just because it's in a public interface doesn't mean it's stable. You still have to make sure that those are methods that are going to be stable before you put them into a public interface. If they are private because they're unstable. Yeah.
Yeah, and that's what that's when you're writing new code, I throw a lot of stuff into private methods. I'll actually leave stuff in public methods until I get tests going how I want them, and then you know, when I should break them out into a new object, sometimes I just throw them inside of private methods and delete
Right.
the test.
Yeah.
Which is probably bad code behavior. But.
Well, people can comment. I don't really know. But yeah, I think she would probably disagree with that, but also it might be one of those things where it's too costly to just pull it out into a new class.
I think she would say that if it's stable and you're not pulling it out into a new class, that you're it's actually more costly, because if it's private, it's harder to refactor.
Right.
Does that make sense?
Yeah, because if it's private,
because you're not actually directly testing the method itself. You're testing the behavior of the method within the context of the public methods, and so that's an extra layer of kind of fog between your actual test suite and what you're testing. And so if you could break it out into a new class and give it public methods that you write tests for, then that's obviously the better option, because then you're getting more granular test coverage.
Right.
That's all in a perfect world too.
Right. Yeah, and as she notes many times, we don't live in an ideal world. So now we go on to going from do not use private methods to maybe you want to test a private method that you shouldn't have. But she does note that, like, maybe you have a mess and you want to wrap it in a private method until you have more information. So you know they're unstable and you want to test it because you don't know if it's, you want to make sure that it's doing what it's supposed to be doing, and it's costly, but it may be less costly than anything else you have available. So she says tests of private methods aren't necessary in order to know that a change broke something. The public interface tests will serve that purpose admirably. The rules of thumb for testing private methods are thus: never write them, and if you do, never ever test them unless, of course, it makes sense to do so. So I feel like this is like everything else. It's like, don't do it. If you have to, don't test them, but also do if you need to. But yeah, so I think that kind of sums it up nicely. It's just really try not to. But she does note that, it's if you need to and you're writing embarrassing code, maybe you just need to put it in a private method and test it and call it a day. So now we move on to testing outgoing messages. And here we go back to queries and commands. We were kind of thinking about what are queries earlier. So she notes again that query messages matter only to the object that sends them, while command messages have effects that are visible to other objects in your application. So she defines query messages again as messages that have no side effects. Nothing except for gear inches cares that diameter got sent. So that
okay, so here we go. So all right. Let's go back a second. I'm sorry, I got it. I zoned out for a second. Okay, ignoring query messages, outgoing messages are outgoing messages are going to either be queries or commands. Because we're wanting to know what a query message was at the beginning. All right, so now let's go to the next one.
Right.
So query messages equals messages that have no side effects. Nothing except for gear inches cares that diameter got sent. Okay. All right. So that's
the diameter method is a query?
Yeah, the diameter is a query.
Okay. Yeah, so she does say the diameter method has no side effects, running it leaves no visible trace, and no other objects depend on its execution. But isn't that not true? This is what I'm confused about, is because like clearly gear inches isn't going to run unless diameter gets sent, right?
It's just
So doesn't
saying
gear
that,
inches depend
well,
on?
all it has to test is that it got sent. It doesn't have to test what the content was.
Oh,
I
okay.
think. Yeah, it just needs to know that that diameter got sent. I think.
Okay.
Because you're actually going to be testing. I don't know. Messages that have no side effects are known as query messages. Here's an example. The diameter method has no side effects. Running it leaves no visible trace and no other objects depend on its execution. In the same way that tests ignore messages sent to self, they also should ignore outgoing query messages. The consequences of sending diameter are hidden inside a gear. Because the overall application does not need this message to be sent, your tests need not care. So gear inches method depends on the result the diameter returns, but tests to prove the correctness of the diameter belong in will, not here in gear. I see. So you don't need to test will.diameter inside of gear.
Oh, okay.
Because it's
Gotcha.
it doesn't care, because that's going to get tested in will.
Right.
So it doesn't care that will.diameter is something in particular, or even that will can send diameter. It just cares about gear. You're going to write the test for gear inches, but you don't need to write a test for will.diameter here.
Okay. Yeah, because that will have already been covered somewhere else.
Yeah. Okay. And so
right?
Dees is listening in. He says, on the current topic, consumers of gear inches don't care how it comes up with the measurement. No other state needs to be changed for the answer to be correct. Gear inch is the only quote user of will.diameter. And because will doesn't change anything after returning the answer, not even will cares that gear inches uses it. So that's
okay.
Yeah, that makes sense.
Gotcha. Okay. Got it. Makes sense. Thank you. And happy birthday.
Yeah, happy birthday.
So, okay. So now we're on proving command messages. Okay, so she says, sometimes, however, it does matter that a message gets sent. So in this case, she kind of comes with this new example where virtual bikes need to know when gears change so they can change their overall behavior. So now we need to know when, what is it? I guess gear inches changes. So we add an observer in line 20, and this observer just sees, just I don't really know.
Let's unpack it here. Hang on.
Yeah.
Let's see. In the following code, gear meets this. Okay. The gear class is now responsible for letting the application know when a player changes gears, so the application can update the bicycle's behavior. So gear meets this new requirement by adding an observer. When a player shifts gears, the set cog or set chainring methods execute. These methods save the new value and invoke gears changed method. Okay, so when you when you say set change, if you look in the code, it says under set cog and set change ring, they both call changed.
Okay.
And so changed has the observer inside of it, and it calls changed on that observer, letting that observer know that chain ring and cog have changed.
Okay.
And it passes in their new value, whatever their new values are, or whatever their current values are. So like if you change the value of cog, it lets the observer know that cog has changed. And if it changes the value of if you change the value of chain ring by setting a new chain ring value, it calls the observer and lets it know.
Okay. So
passing in the new value.
Okay. So I'm a little confused here because it looks like within the changed method, it looks like it's being
So
passed
observer is going to be another object that got passed in when you initialized. So if you look up
Okay.
there in the initialize, it says observer
Gotcha.
equals our observer. And then whenever you make a change, it's letting the observer, which is another class that's outside it, that's not actually gear, know that gear has changed. So like, let's say your bicycle needs to know when the gear changes. You may pass in or whatever. Let's say you have or some kind of, or maybe it's some kind of like monitor, like some kind of, you have some kind of monitoring object that says, you know, like that keeps track of like changes over time or something. Then every time you make the change, you pass in the new value or the current values, the new, you know, whichever one has changed plus the other one, and it does something with those.
Okay. Yeah. Gotcha. So, okay, that makes sense. So now, right, so now Gear has a new responsibility. It needs to know that change got sent. The responsibility for testing a message's return value lies with the receiver. Okay, got it. So that makes sense. So in this case,
you would need to change. You would need to test changed, and you would need to test changed on the observer as well.
Okay. Okay. So this is also where I get a little confused because I'm not really understanding what like I get what a mock does. I don't really understand what it is.
Is this where she starts using a mock? Yeah, it is, isn't it? Okay, so
yeah.
So a mock it's an object that that just pretends to be something.
Okay.
It's a pretend. So okay, so because because you're not actually sending any data to an observer in your test suite, because you're not actually passing in an observer, you just want to pass in something that's going to take the thing and play nice with it, and that's what the mock does. The mock just takes it and silently accepts it and doesn't blow up.
Okay, so is that a feature of Minitest or is that a feature of like
mocks
Ruby?
are something that exists in any kind of fully functional test suite.
Okay, so that's not syntax.
No, mocks are, so doubles and mocks are both things that exist in test suites.
Okay, gotcha. Okay, so it says this mock injects in the place of the observer. Got that in line 8. Got it. Test method tells the mock to accept or receive to, I don't know what I was supposed to write there. That doesn't make any sense.
Let's see. Okay, she's got two tests in here. She has a mock, which is an observer. It's just a mini test mock new. And you have a gear, which is a gear.new with a chain ring, a cog, and the mock. And then she has two tests. She says observer, which is the mock, expect changed, and then these numbers, and then she runs gear.setCog27, and it says observer.verify. And let's see, because mocks are kind of new to me too. Right. All the mock did with the message was remember that it received it. If the object under test depends on the result it gets back when the observer receives change, the mock can be configured to return an appropriate value. So in this case, she didn't need it to return an appropriate value. She just needs it to verify that it received the message.
Okay, so yeah, we got some input on Slack. So let's see, he says mocks are one of several different types of objects called test doubles. For the purposes of a test scenario, the mock plays the part of an object that a tested object depends on. Mocks are more sophisticated than dumb test doubles and can report on what was called on them, etc. Okay. So, Okay, that makes sense.
Yeah.
So,
And so that's when she says, observer.verify in those tests. That's just verifying that it got the message.
right.
Because you're actually testing to make sure that the message got passed to the observer.
I see.
And he said something else. A more common and simple test double is a stub, which just fakes some data response to feed the test scenario, but doesn't do any observation or anything like that. A stub can be as simple as hard-coded data value.
Yeah, and I think she does get into stubs, so I think that's actually next.
Coming
So,
up. That may be what she does with
takeaway.
that types.
Yeah,
Maybe.
I think so.
Okay.
All right, so here again, all the mock did with the message was remember that it received it. Setting expectations on these mocks allows you to prove that the object under test fulfills its responsibilities without duplicating assertions that belong elsewhere.
Right.
Gotcha.
So it's a way of isolating the test again. You create a fake object that just recognizes that it got the message.
Okay, so it's not like it's, so with the test double, you're kind of creating something that has a tendency to mask what might be really happening. And
Well,
with mock, or is it just totally different?
The mock just says, yeah, I got past something. When you called set cog, it did something to me.
Okay.
That's all the mock's doing here.
Gotcha. And it's
so in the two tests, if you look at the two tests here, you have the first line is the observer, and it's going to expect that it's changed and that it's gotten this message, 52 and 27. And then your dot set 27, when it does, because 52 is what chain ring already is, it's going to say, yeah, I got 52 and 30 and 27. And then the one below, when you call set chain ring to 42, it's going to say, since the default cog is 11, when you call set chain ring 42, it's going to pass 42 and 11 for the chain ring and the cog. And it's going to say, yeah, I got that.
Okay.
What it does with it doesn't matter.
Gotcha.
It doesn't actually do anything with it at all other than verify that it got it.
Okay. So does it return, is it a Boolean then?
In this case, it's just gonna verify. The test is just gonna pass. Yeah, it's just gonna verify that it got something.
Okay. So we've got more info coming in on Slack. Test doubles in general are fake objects that stand for the real thing, so that your test is only concerned with the behavior of one object at a time. Right. And so that's what we did with
that earlier test
diameter.
Double.
Yeah,
the diameter double. Mm-hmm.
So that was a test double.
That was one where we were actually passing in. We were passing in and then calling a method on it. In this one, we're passing it in and calling a method on it, but we're only calling a method on it for the purposes of giving it information. We're not worried about what information it returns. We're worried about the fact that it got our information.
Okay, so we just need to know, like, you got it.
Yeah.
And then, okay. So I think it got still a little fuzzy on that, but I think it's just one of those things that I need to do. So next we get to testing duck types. So she explains that this section shows how to create tests that role players can share and then returns to the original problem and uses shareable tests to prevent test doubles from becoming obsolete. So first we go into testing roles. We're using a code sample from chapter 5. So here's a reminder of the original code. What the actual methods contain isn't important, so that's why it's kind of dotted out, but we're using 3 classes: mechanic, trip coordinator, and driver. Mm-hmm. And I don't think we actually get into what the actual methods are, but
so those are all when you want to prepare a trip, the coordinator needs to buy food for the trip, the driver needs to gas up and fill the tank.
Right.
And the mechanic needs to prepare the bikes.
So this was like the first iteration of, so we get to this trip class and we see all this ridiculous case switching and we're like, hey, maybe this would be a good duck type. So we see that it checks the class and that's our red flag. So this is one of those things where she gets into saying like, this might be better to refactor first rather than write a test for it and then refactor, because the test would be painful to write. Like it would just be too costly to write. Wouldn't be worth it.
You're going to have a huge test. You're going to have to, you're going to, if you're only writing one test for prepare, your prepare test is going to have a ton of expectations.
Right. Like I can't even like begin to think of what that would even look like.
It would just be it'd be a big spaghetti mess, and the more classes that you have that it could be, the bigger of a mess it gets.
Right. So she says, let's refactor. So we get to basically what we got to in the chapter 5 is we found this duck type, this prepare duck type. So now they all have prepare trip in common, and just kind of as a reminder to myself what a duck type was. Prepare trip is a method that's called in each prepare class, but they don't necessarily do the same things. But now we have this kind of class of preparers that can refactor, and we can refactor trip very easily.
Right.
Yeah, so now we refactor trip without that nightmare case switch. And now we can write tests that aren't completely out of control. And she also says, keep in mind that your tests serve as documentation of these roles. So this test will kind of name the preparer role. And I'm doing air quotes, which obviously you can't see, but name this preparer role within the test so that other people can kind of see what that is and know what the requirements are. So, okay, here we are testing roles. Lots of things act as preparers. We should only have to write the test once. So we write it as a module, prepare interface test. And we basically just say, does this class respond to a prepare trip? If it does, it's a prepare class.
So,
or it's a prepare duck type.
If you look there where it says assert respond to and then object, I think we defined at object. Well, don't worry about it. Yeah, each one of them. Yeah, there it is. Each one of them inside of the setup, it defines what the instance variable of object is, which is its self. So basically, it just says self.prepare trip.
Right. Yeah, so just making sure that it can respond to that.
Right. And
Right. So then we've got you include this module on in this example, it's mechanic test. So we can check if mechanic is a prepare, i.e. has the method prepare trip, which it does.
Yeah.
So we also do the same thing with trip coordinator and driver. And these tests pass, and we know that these are all definitely preparers. So is this testing?
This is just testing that it has a prepare trip method and that it responds to prepare trip when it's called on it.
Right. So, but would this be testing an outgoing message? Is prepare trip an outgoing message? No, it's not. No. It's an incoming message.
Yeah, trip gets passed in to the prepare trip method, and you prepare the trip. You do whatever you're going to do to the trip object, and then return it.
Right. Okay. Okay. Yeah. So now now that we know all these tests pass, we know they're definitely not preparers. So now that we have now we have to prove that trip correctly sends prepare trip. So in this case, we'll create a mock, tell it that it should receive prepare trip, trigger trip, and then verify that the mock got prepare trip. So,
and it uses the same interface there as all of the preparers do. So you see it says prepare.expect that when you call prepare trip and pass in the trip, that I'm not sure what the nil is there from any test, but yeah, it's going to verify. Then when you call trip.prepare preparer, it's going to verify that the preparer did what is expected.
Right.
To trip. That it did something, and then return trip.
Right. So basically we just, and this test does pass. So now we know that the prepare role tests are complete, which is cool. So we tested the classes to make sure that they were preparers, and now we are testing trip to make sure that it correctly sends prepare trip.
Right.
Okay, so next would be using role tests to validate doubles. And we just kind of talked about doubles. This is on page 224 if anybody's lost. So this code is a reminder of the faulty passing tests that return a misleading false positive. Diameter double does not play the diameters role properly.
So you're actually going to include something in the diameter double, right?
Right. Yeah, so I think that is, no. Okay, so, where do we, so I think, okay, this next part is,
okay,
line 6, no, where are we?
Yeah, we have a test that, so she writes a test that proves that Will has width method. Assert, respond to, and it does. Like there's a method for width now, and it responds. So that test she wrote, but the diameterizable, which is that is acting as the will for the purposes of the gear test, it doesn't have width. It has diameter, and so when you change will, it does. And if you forget to change diameterizable, if you forget to change diameterizable, it hides the fact that things are actually going to blow up in implementation. So we have to fix that. This will be the next slide, I think.
Yeah.
Using roles test to validate doubles. Yeah. So she extracts the diameterizable interface, assert, respond to object width, and then she includes that in the will test.
Yeah.
Test calculates. So you have to do that. So you need to create that interface if you decide you're going to double, if you're going to write the test doubles, because that way it'll blow up on the test double and the will. If you change,
right.
You know, if you change one, it'll blow up in both of them.
Okay. So, right. So at this point, wheel test works just as it did before the extraction, and both of the tests pass. So we can see that it works. Let's see. So it says now that you have an independent module that proves diameterizable behaves correctly, you can use the module to prevent test doubles from silently becoming obsolete. So
Yeah, so the diameter double there, you write a test, you have a test for it. You have a class that's a test for the diameter double.
Right.
So you're actually testing the will and the diameter double using the exact same
Right.
module. And then
Because
you
it's, yeah,
you
because
don't
it's also
actually,
part of the interface. So you have to
yeah.
test with all of the things that are part of the interface.
And since the diameter double is only doubling that one thing, you don't actually have to write any tests inside of your diameter double test. All you have to do is include the module, and the tests are automatically inside of it.
Right.
So you just include the module in the double test and whatever it's doubling for, and if you change one, it'll blow up. And then
Right.
if you then so like let's say you change will, it'll blow up in the interface test. And so then you go in and you fix the interface test. Well, then it'll blow up in the diameter double test.
Mm-hmm. Right. So yeah. So now
Or not even the diameter. Sorry, it'll blow up inside of the gear test.
Right. So yeah. So what we were getting before, we were getting false positives. Now we're getting a fail on the diameter double test.
Mm-hmm.
And it says explicitly it doesn't respond to width. So you know that somewhere in there you either forgot to change everything back to diameter, or you forgot to change everything to width. But
Right.
one way or another, you know that method is wrong. And that's what we want to do because we want our tests to break at the right times.
Right.
So now we changed diameter double to width because we know that's wrong. But it still fails. And we ask ourselves why. And you look at the test and it says, test tells us the problem is in gear inches. So now we've actually gotten to the root of the problem, which is the point of the test in the first place.
So if you don't write these modules to test the doubles as well, you actually have your test suite working against you.
Right.
Because when you refactor, you're going to have it telling you that everything's fine when it's not. And so your test suite, it's actually worse than not testing it because it tells you it's okay when it's not.
Right. Yeah, because then your application breaks, but your tests don't. So it's like you think everything's fine.
Right.
And it breaks, you don't know why.
Yeah.
So don't want that to happen. Okay, so, and this is kind of, this is the actual bad line of code that we need to change. So we need to change diameter to width, and now all the tests pass. So the desire to test duct types creates a need for shareable tests for roles. So yeah, so we worked through that, and now we finally got to the root of the problem.
So yeah, if you're going to have duct types, you're going to have doubles. If you're going to have doubles, you're going to have those modules that test the doubles.
Right, right. So it might seem like some more work, but in the end, your tests pass correctly. It's great.
Which, I mean, it makes sense that you would always have doubles when you have duct types, because the whole point of a duct type is that you've got a whole bunch of classes that are doing very similar things and have the same kind of interface, but are different under the hood a little bit. And so that's exactly what a double would be. Like a double is going to function in the same way. That it's like it's going to have the same interface, and it doesn't care about under the hood.
Right. Right. Yeah.
So that makes sense. That you would always, and so yeah. Anytime you have a a duct type, unless you want to have a crazy amount of tests that all do the same basic thing, you're going to have doubles. And anytime you have doubles with the duct type, you're going to want to have tests on your doubles. So okay, cool. Good to know. Yeah. I'm sorry I repeat things. I'm internalizing it for myself.
No, I think that's really a good strategy, actually. So the next we move on to testing inherited code. So now we're going to work through the code example from chapter 6, which was acquiring behavior through inheritance. And we eventually refactored the code out of needing inheritance, but it was still okay to use at that stage. We just used modules in the end instead of inheritance.
Classical,
but you can, it's still usable. Right, yeah. So here's what we're working with here is the last kind of iteration of that before we refactored it completely out of classical inheritance. So we've got our bicycle class with methods of spares, default tire size, post initialize, local spares, and default chain. So that's our abstract. So road bike is a subclass of bicycle, and here we've got post initialize, local spares, and default tire size. So that's, and also everything inherited from bicycle, so all of those methods as well. So now that we've kind of reviewed the code, she says the first goal of testing is to prove that all objects in this hierarchy honor their contract. It must obey the Liskov substitution principle, which I believe, which I don't remember the exact, but it basically just says that all of the subclass have to act like it's superclass.
Yeah, they have to implement the methods of the superclass.
Is that what it was?
Yeah. She repeats it in there somewhere. What page are you on now in the book?
I'm on 230. I believe it's defined on page 160. So she says the definition of it is
well, on 230,
in order for types,
subtypes should be substitutable for their supertypes.
Right. Okay. Yep. Subtypes should be substitutable for their supertypes. Right. So she says the easiest way to prove that every object in the hierarchy obeys Liskov is to write a shared test for the common contract and include this test in every object. So any object that passes these tests, we can trust, in this case, to act like a bicycle because it has all the components necessary to be a bicycle. So this is the bicycle interface test, and she's written it out, and it makes sure that it responds to default tire size, default chain, chain size, tire size, and spares. So the test we just wrote is included both by the abstract superclass and the concrete subclass. And this makes sense because the subclass has to be substitutable for its superclass, like we just said, so it should pass all of those. In this case, all of the tests pass. So not only do all bicycles share a common interface, the abstract bicycle superclass imposes requirements upon its subclass.
I'm gonna interrupt you for just a second.
Yeah.
He says in the Slack channel, he gives a link to the Liskov substitution principle. He says whenever you use an is-a relationship, which is what we're doing here, the thing that is something must be able to be substituted for that something itself. Otherwise, you're doing something funky.
Gotcha.
Okay.
Right. So that, yeah. So in this case, it'd be relationship between road bike and bicycle because road bike is a bicycle.
Right.
There's no denying that. So confirming subclass behavior. Subclasses should share a common test to prove that each meets the requirement of being a subclass. So in this case, we just have the one, so we have the one kind of superclass test and the one subclass, but we need to include both of those in every subclass.
You're going to include the bicycle interface test in both the bicycle class, or in both the bicycle test and the road bike test, but you're going to include the subclass tests just in the subclasses.
Mm-hmm. Right, right. But then from there, I mean, all of the subclasses will only have, you know, they'll all look exactly the same in terms of what their tests look like, except for the class name themselves, which is, I think, really, really, really cool. And it makes it, you know.
It's interesting. She's being pretty broad in what she's calling tests. She's saying it's going to respond to this stuff, but she's not saying like, what, she's not asserting any kind of like expectation about what the response is going to be.
Mm-hmm.
which is interesting.
Right, and I wonder if that would that be a separate test?
I guess you could, if you wanted to get more granular with a specific subclass, you would have individual tests for each one of those subclasses, but then you would still have the mixins that just assert that the public methods are present and respond, and that the object responds to when you call those public methods.
Right. Yeah, so I guess in this case, she literally is just testing
that the methods exist.
Right, just that it like is a bicycle subclass.
Yeah, it's all it's saying. All it's testing is that the methods that are supposed to be present are present.
Right.
It doesn't say anything about what those methods do when you call them.
Right, or what they do, what they like should be or should not be.
Mm-hmm. Yeah, it's just asserting that they're all public methods that exist in this class.
Yeah, and I guess that makes sense because you want it to be, I mean, you want it to be broken down, right? Like,
right. So like road bike
test that it's a subclass.
The local spares on road bike tests, the local spares on road bike tests and the local spares on street bike tests are going to return different values.
Right.
So like you would, if you wanted to actually test what those values were going to be, you would have to write individual tests for each one. All this cares about is the fact that they have the methods that do return a value, not what the specific value is going to be.
Right. So I guess in that case, if you wanted to test if, maybe it's only a road bike if the default tire size is between a certain size range, would you test that within the like road bike test itself?
Yeah. So Dees says here, he says I said it. Testing the interface is satisfied, but the behavior of those methods must be tested individually since each one should be different.
Okay. Yeah.
So you're going to actually have tests inside of your bicycle subclass test suite, but you're also going to include the modules, assuming you want to get granular with what those methods are going to return the right thing, which I would think you would in most cases.
Right. Right. Okay.
She's just showing a way that you can. She's just showing a way that you can actually test the broader abstraction. That the broader abstraction is present.
Mm-hmm.
Steve says it's possible to expand that interface contract to make an assertion about the value returned, such as that it is a certain type. If they all return a certain type, then yeah, you would do that.
Mm-hmm.
Okay, that makes sense. So yeah, instead of just asserts respond to, you could do like asserts returns this type of thing, like a string or whatever.
Yeah, and he adds, but it's best to test types by their interfaces, not their names, since that's a form of coupling.
Right.
True. So,
okay.
Yeah. Makes sense.
I'll turn the dryer on.
Okay, so let's see. Confirming subclass behavior continued. So in this case, we can literally just we haven't looked at mountain bike since chapter 6, but we know it's a subclass of bicycle, so we can just include those two mix-ins there with the bicycle interface test and bicycle subclass test, and we know straight off the bat that like if it passes, then great, it's a subclass and we've got it. We don't have to worry about it.
You've confirmed that you have the interface of a bicycle and that it acts as a subclass of a bicycle. Right. And then what it actually does beyond that would be your actual individual tests.
Yeah, so it says these tests give you the confidence that subclasses aren't drifting away from the standard, and also that newly arrived programmers don't have to scour the superclasses to unearth requirements. So here you can tell kind of exactly where everything comes from and where it needs to be, and it's documented.
And also, if they write a new, let's say they write a new bike, like a new subclass of bike, if they include those two modules and they don't pass, they know they haven't gotten the interface correct. They haven't gotten all the methods they need.
Right. So that's the, yeah. So I guess it would make sense, like if you were just coming across this code and it was your first time looking at it, you would want to write a test first and make sure that whatever you would want to, like, basically just copy this test and change the descriptor of mountain bike to some other kind of bike, and before you wrote the class itself, so you know that it passes.
And then all you got to do, once you get those two modules mix-in, once you get those two mix-ins passing, then you know you have the right structure, and you can start futzing around with what those individual interfaces return. Then, but you know you have the right structure at that point.
Right. Right. So and I guess if the right, like if the other test had, you know, we're testing other things, you could address that at that point. But once you get this like simple one to pass, and you know you're good to go. So also confirming superclass enforcement. So here we see that the bicycle class should raise an error if a subclass does not implement default tire size. And this is seen in line 5. And we have to add in the tire size argument because bicycle doesn't have a new method. We can circumvent that by giving it the tire size method. So it's just the way that the bicycle class was written. But you obviously have to be able to instantiate a new bicycle class because we need it to test, but you kind of have to do a little work around there with the tire size.
Yeah. So I actually, that one kind of threw me for a loop for a little bit. But yeah, you're just passing in that tire size block there, or that tire size hash as an argument, and that way you're able, because normally you would never instantiate just a bicycle. The bicycle's just acting as an abstraction.
Right.
But you, in this case, you're able to, without it exploding, if you pass in a tire size. Because it looks, if you look there, it says, when the test below, if you call just default tire size on it without having one, it's going to blow up. And then let's see, where's look at bicycle interface. Bicycle interface calls. I'm looking at what the bicycle interface is.
231? Responds
to default tire size, responds to default chain, responds to chain size, tire size, and spares. Yeah.
Right. Yeah, so let's see. So these tests, pass because they do. I mean, okay.
Oh, you skipped. Oh, yeah.
I will skip back. Just wanted to see what so this is kind of like the last part of testing the
superclass.
Yeah, the superclass. So now we're moving on to testing unique behavior. So we haven't yet covered specializations, and this is what we were talking about earlier, saying like, what do you do if there's other things within that class, that subclass you want to test. So here is an example. So in this case, like specializations, in this case would equal like road bike supplies, which are different, than other bikes don't have the same supplies. So in this case, it's the handlebar tape color, and you need to test it without knowledge of the superclass. So line 9 tests specialization directly. We got line 9 as test puts tape color in local spares. So here you put a red tape color within the local spares, and these tests pass.
Right. So in our modules, we're just testing that the interface is there. This is testing that the interface is giving us what we expect it to give us.
Right.
Which
So,
in this case,
okay.
yeah.
Yeah. No, I was just agreeing. Yeah, that's what we were talking about earlier. So, okay. So did that, those concrete subclass behavior and are on abstract superclass behavior. So provided it doesn't violate listgov, you can supply stubs via subclass creation anytime. And this is what we kind of touched on. So I am a little bit fuzzy on kind of what this means.
Let me look at that. Stubbed bike. So a stubbed bike, it's like a fake, instead of a mountain bike or whatever, it's a fake bike. Like it's a fake subclass.
Okay.
Does that make sense?
Okay.
And so it has a default tire size and it has a local spares, but it's not a default tire size or a local spares that actually exists in any of the subclasses that we actually implement in our code base. This is a new subclass of bicycle that just returns 0 when you call default tire size and that hash when you call local spares. And then that can be used to test the bicycle interface, because you just say bike equals object equals bicycle.new with a tire size of 0, and stubbed bike equals stubbed bike.new. And then in the test, you say, well, the new one is the test includes local spares and spares. So if you call stubbed bike.spares, it gets that back from the bicycle, because the bicycle has a spares class. You give the bicycle local spares, but you see at the very top line it says the stub bike is inheriting from bicycle. So the stub bike has all of the methods that exist inside a bicycle, and one of those is spares. And you're actually testing that when you inherit spares from bicycle and pass in this data, you're getting back the expected result. You're actually testing the expected result of unique behavior for bicycle.
Okay.
By making a fake subclass. So you're not actually having to, this way you're not using mountain bike or something like that to test bicycles' expected behavior. You test the superclass with a stubbed fake class that just has those two methods. Let's see what these says here. Clayton, since you only want to test the things that the abstract superclass provides, you can create an oversimplified fake version of a bike subclass to verify the standard inherited stuff on. You give the test a way to look at the qualities of the superclass, since the test knows that the subclass isn't adding anything serious to it. Okay, yeah, that makes sense. So because you're only giving it those two small things, you know you're limiting the amount of behavior that could be coming from, for example, the fact that it's a mountain bike versus a road bike or whatever. You're giving it a very limited amount of possible stuff, just enough to implement that spares method, and that way you're actually testing the behavior within bicycle, not the behavior within bicycle subclasses. It's a way to access the behavior inside a bicycle and test it. That makes sense.
Yeah, that makes sense. Yeah, so you're not like, yeah, okay. So you're not like accidentally writing a test just to test just that like goes with the stuff they already have.
Right.
Right.
You're not testing the subclass. It's not dependent on any particular subclass. You're testing the actual superclass with as little amount of data as it takes to get the bicycle to respond intelligently.
Mm-hmm. Okay. That does make sense. So, okay. So, and the provided it doesn't violate OSCOB, you can supply stubs via subclass creation at any time. So testing abstract superclass behavior, use bicycle subclass test to ensure the ongoing correctness of stubbed bike. Yeah, so
it has the, and all that says is it's going to respond to default tire size and local spares.
Mm-hmm.
Yeah, and which it does. It has those two methods. It's just those two methods just return this little bit of data.
Right, but because it is a subclass of bicycle, you need to define it within that interface, right? So this is like documenting that it's part of that interface.
Yeah, it's just that way. If you go and change the interface in mountain bike and that stuff, your classes will break in. If you actually change the bicycle subclass interface, you want that to show up in your test for bicycle, and this allows it to do so because your stud bike test has the same. It verifies that it has the same interface as all the other subclasses.
Right. Yeah. Yeah. So cool. So I think so
That's it. We're at the end.
That's it. I cannot believe that we got through that entire chapter in roughly an hour, 2 hours.
That was huge.
2 hours. Yeah, that was a huge chapter. Summary: tests are indispensable. The best tests are loosely coupled to the underlying code and test everything once and in the proper place. So
Yay.
That is exciting. Yay. We finished POODR, and that's great. Let's see. Okay, I'm going to stop sharing my screen. Stop sharing. So, okay. Now I am. So yeah, so I like wrote in my book, you finished. Hashtag congrats. Because I was excited. So,
awesome.
Yeah, so yeah, that was cool. So also on the, oh, you know what? I had one last slide. Let me put that up real quick. I've already shared this in the Slack group, but you know, for people that are watching from the future. And the afterward, she says, persist, practice, experiment, imagine, do your best work, all else will follow. And I thought that was really great. So I included that. Okay, so let's see. Okay, so cool. We are done with the book, which is super cool. Because I couldn't tell you the last time I read like a technical book cover to cover.
I don't know that I ever have.
Yeah, you know, I don't know if I ever have either. Well, the exception I think is this one, which is a picture book. So, and even that took a couple weeks.
So I've already started using a lot of this stuff in my code.
Yeah.
Yeah, like I wrote a gem recently that was trying to take these ideas and implement them on Struct.
Right.
Thanks, Steve.
Yeah. Yay. So yeah, your gem. Talk about it real quick, because I didn't really grasp what it was.
So let me give you a link to the README real quick too. So it's called because it follows struct, so structure.
Right.
And it the idea is that it's a struct that has required keyword arguments, and he wants me to show off the gym. I guess I can share screen actually, huh?
Yeah.
Let me open up the gym. Let me actually open up the gym and show you what it does. Are you seeing my terminal?
Yes.
Okay. So I open up pry. I'm going to require and so in struct, let's say I have a struct. So I'm going to say car equals struct.new, and my car is going to have paint and a year that it was created, right? So I have a car, and let's say that my car is BMW, or not, equals car.new. Now, if I, for some reason, if I give it a paint, or well, actually, I can't give it a paint. If I can say the first one's going to be, it's going to be a red BMW for some reason, and it's a 1965. Okay, so it creates the new car, and then my BMW has a paint method, and it has a year method, and it returns those two things.
Right.
So let's say now I have a van, and I just want it to be a car.new. The only problem is it'll create it with nil. So if I say van.paint, my van doesn't have any paint.
Right.
My van doesn't have a year. That's no good. That's no bueno. I don't like that. So that's why I don't use structs much, because you can initialize them without. And also, if you notice, when I actually created when I created my BMW, I had the arguments had to be in a certain position. So the red had to be first, and the 1965 had to be second. So if I did a BMW again, if those switched, 1965 and red, it's going to act. It's going to act like I gave it the right thing. So if I say now BMW has, if I say year, it's going to tell me the year's red. Right. That's no good.
Which is nonsensical.
Right. That's no good. So I already required So let's actually exit out of Pry and start a new session now. Okay. Now I'm going to require again. I'm going to say this time that car equals .new. And I'm going to say that it has a paint and a year. Okay?
Okay.
So my van this time, if I say van equals car.new, it blows up. And it tells me I'm missing a keyword for paint. That's great. That doesn't assign it with nils. And if I sell it, okay, well then let's give it a paint. I'm going to say the paint. Let's do it like I did with the struct. If I say it's going to be red and 1965 again, it's going to blow up again because it says I have the wrong number of arguments. I need a hash.
Oh.
So this time it's required keyword arguments. The paint has to be red, and the year has to be 1965. Oops. 1965. Great. And now I have a van with a year and a van with paint.
Cool.
Cool. So what if I did that with, what if I did the order different? Year 1965 and paint red. It works again. And it still gives me the same thing. It doesn't care what order you give the arguments because they're required and they're named.
Right.
So that's cool.
Yeah.
So one of the cool things you can do with a struct, or at least with an open struct, it has the ability for you to reassign van.year equals 2000 with an open struct. You can do that. It'll blow up if you do that with here. It says there's no year equals method for car. Yeah, so once you've created your object, it's immutable. It stays the same. So it takes required keyword arguments. It doesn't care what order it gets them in, and something won't change it later. So it's like defining attribute readers. Remember when Sandy talks about defining attribute readers?
Yeah, I remember that.
It essentially it defines attribute readers on your struct, but it doesn't give you accessors. You can't change it once you've created it. It's immutable. So that was the thing that I created.
Cool. That's really neat. It almost seems like that should have just been there from the beginning.
Well,
but that's like obvious, like why it should be there.
So required keyword arguments are actually a pretty new thing in Ruby. So the fact that what I implemented is not technically actually required keyword arguments. What I wrote is a workaround that makes you give it required keyword arguments, but by passing in like a hash, but the interface is basically the same. But yeah, Ruby required keyword arguments are kind of a new thing in Ruby, and and so it's not like I had found structs that there's a really cool gem called, I think it's called values, that has several different versions of structs that are all different than the actual struct and open struct interface. And one of the versions is that it's immutable, which is what I have. And that's great. That was cool. But I was like, I like that it's immutable, but I wanted to have required keyword arguments like the later versions of Ruby. So I had to rewrite it with that. And so that's what I did. I wrote like the initial version on like Sunday. And then I spent the last week getting it working again, like working without getting the bugs and kinks worked out of it. And it's actually a pretty cool tool. I think it's actually going to get used.
Have you used it yet, like within your application?
No, I mean, I just finished like getting the last bugs worked out a couple of days ago, so I haven't had any chance. And to be honest with you, I haven't run into any situations where, because I don't like struct, I haven't been keeping a huge eye out for opportunities to use it, but I will now.
Right. That's really awesome.
So yeah, that's all inspired by Sandy's book, like the ideas that she talks about in her book.
Right. That's really cool. I mean, that's like, that's great. I'm just like so blown away that you just like made a gem, and it's cool and it works.
He says, yeah, struct predates keyword arguments, so maybe Ruby 3.0 will include a Clayton struct.
That'd be cool.
And he says it's not obvious for beginners that immutable equals good. And I agree for the purposes of structs that immutable is a good thing. In Ruby is not like a lot of things in Ruby you write not to be immutable. But I think like data objects, the whole point of data objects is that they're things that hold data, and you don't want those to change. I don't understand why Ruby has structs the way it does. Like I'm sure there's some, the fact that open structs exist in Ruby means that there's some point in having them, but I don't like using them.
Right.
They're not immutable. I want my data objects to be immutable.
Well, cool. You like solved a problem.
Yeah,
That's really neat.
I have to give credit where credit's due. I got stuck a couple of times, and I got some help from James Edward Gray on it. He was really helpful. So, because it got pretty low level. It inherits from basic object. So when you actually create an instance of it, you have almost no methods, which is good because it's dynamically generating methods. So you don't want to have a bunch of methods because you don't want it to accidentally like overwrite, I don't know, like each pair or something like that. You don't want to pass in a keyword key and have it overwrite some method that exists in Ruby. So I wrote something that has almost no methods at all by like default.
Right.
and then just re-implemented the few methods that I wanted. But because of that, it was really limited. It took me a long time, for example, to figure out how to pass in the right kind of scope just so I could create an equals equals method. Like that was the hardest method to write, was the equals equals method, because I had to figure out how to pass the right. I had to figure out how to make it tell that it was the right kind of thing.
Right. Well, and how long did it take you to build this?
So I wrote the first version in a day.
Uh-huh.
And it was all buggy, and it didn't have the equals equals method.
Mm-hmm.
And then I've just been working on it since then. And I got a version of the equals equals method working on like Tuesday, maybe. And it was still, like, I thought I had it working. And then James, like, I sent James code, and he's like, try this. And when I tried that, it shouldn't have passed. Or he's like, write this test and run it. And I wrote the test, and it should have passed, and it didn't.
Uh-huh.
And so I had to figure out like how to get it going. But yeah, I worked hard on it, and I'm pretty proud of it. It's a really good gem, I think.
Yeah, you definitely should be proud of it. That's awesome.
It still has a couple of public methods. I want to add JSON interfaces to it, but I don't think that's going to be super hard. So I haven't tried to do it yet, and I didn't think equal equals was going to be super hard either, and it turned out to be kind of a pain.
Right.
So hopefully, hopefully when I get back from RubyConf, I'll have some time to work on it, or maybe even while I'm at RubyConf.
Yeah, that might be a good opportunity, and like hang out with people and like figure out.
Maybe we can pair up on it or something.
Yeah. Have you thought about doing a lightning talk on it?
Yeah, James is going to try to talk me into it. I can already tell.
Well, you should probably. I mean, like that was your lightning talk right there. You literally just did a lightning talk on it. So there you go.
Yeah, maybe. I don't know about live coding during a lightning talk. That seems really dangerous.
Well, you could also just like have your PowerPoint slides advance.
Yeah,
as if
I would have to do that.
Yeah. So okay, before we stop broadcasting, so we're done with the book. For all of those who are watching, done with the book. We are thinking maybe we'll pick up with something mid-January, just to give everybody a break for the holidays, because I know it's a hard time to commit to anything. So if you have suggestions on books we should do next, put them in the which channel, because we're not technically the POODR channel anymore.
I think we should probably retire the POODR channel soon and move all of the the playlist and everything over just to the Ruby channel for now. Okay,
the Ruby. You don't think the book club or just the Ruby channel?
The Ruby book club would be a good place for it too.
We could also put them in both.
There. We don't have to do a Ruby book next.
Right, that's true, but
yeah,
it'd be fun. So we're taking suggestions. Doesn't have to be Ruby book. We're thinking about maybe doing that one that was the Rails sequel to this book by somebody different.
It was one of Opti Grimm's books.
Right. I don't remember what the title was. Somebody suggested it like
Objects on Rails.
Objects on Rails. Okay, so that was a suggestion.
Yeah, that one's by Opti Grimm.
Okay, so one suggestion. We also kind of discussed maybe doing, instead of a book, doing kind of articles or like long form, blog posts, and just doing maybe one of those a week. And maybe if we don't decide on a book by mid-January, we can kind of do that instead. But then again, we'd have to find an article every week, so it might be more difficult. But anyway, taking suggestions, drop them in the Slack channel or on the comments on YouTube. I will get those notifications and I will take them into account. And also, I guess we could be potentially open to changing the time. Maybe not the actual like 9, because I think 9 p.m. works for 9 p.m. EST works for most people, but the day. So if you have opinions on what day, also let us know.
And that's months from now, so
yeah,
lives can change between now and then. I don't expect I'll have the same job by then.
Yeah,
I'll be mad if I have the same job by then.
well, you should. Yes, I don't think you will. I trust that you will be moving on to coding. by then. Well, you have you've got a job offer, right?
Yeah, I think so.
Okay, so we're looking at, quantum life changes between now and January, but keep it in mind. Anything else? Any last housekeeping? I think that's it.
Come to RubyConf.
Yeah, RubyConf is in 2 days. Oh, I guess RubyConf will be doing if you're going to RubyConf 2015, we're going to do a book review session.
We're going to talk about POODR.
Yeah, it'll be fun, and it'll be live and in person. I'm not sure how we're going to record that, so maybe we should think about logistics.
Actually, shoot, 10:30. I need to make a phone call about that.
Okay.
All right, I'm going to go.
Cool. All right. See you later. See you this weekend.
Yeah.
Bye. Okay, and that is it. See you in January.